So good morning all. Give me a minute to get my slides up and I'm going to start screen sharing here first.
It's working?
Yeah.
Yes, coming. Which island is this?
Island of the mind.
What happened here?
Should be
There we
should
go.
be one of the islands nearby California state. Yeah, according to my memory, Apple have stated clearly why they would like to choose this island. Anyway.
We don't have your voice, Jerry.
Oh, we should have it now.
Yeah.
Okay.
Yes. Yeah.
So I have to go back. Okay, are we, oops, we've got one more.
Good morning.
So good morning. So semio-cybernetics is a term that is I've sort of constructed for the particular purpose of this talk, in the sense that it is a reformatting, I guess would be the right way to say, of molecular biology into a common language that is used within the cybernetics community. As such, it's a major challenge to reformat the languages that are involved with the different symbol systems that are used in descriptions of life and culture and society, etc. So this is an effort to reformat my thinking in a certain way of looking at this. Thinking because I'm trained as a biochemist and a molecular biologist originally. The notion of hylomorphic logics is referring to then the Greek word of hylo, which we'll come to, as being material or associated with material causality. And the notion of denoting is from Bertrand Russell's notion of famous paper on denotation and its relationship to atomic and molecular sentences. And for this group, the notions from atom to anatomy is taken in a categorical sense of atoms being extremely small logical particles from which we construct the anatomy of life. And so that is an effort to bring into the title the various concepts that will be described or discussed or ascribed to cybernetic systems of life. So that is what I'm going to summarize here very hopefully precisely, but probably more concise than precise, is roughly a half a century of work, starting with my original observations with regard to cybernetic control of metabolism in the organism E. coli and in the relationship to the biosynthesis of a critical energy metabolite called niacin or NAD. So this is the critical notion here is that we're going to talk in terms of material causality that is demonstrable in the laboratory or in the clinics. And so this is an axiological notion that is related to axiomatic notions by the notion of conversion of one language to another language. So what is hylomorphic cybernetics? Hylo, as I said, is the Greek term for substance or matter, and hence the notion leads to the notion of material causality in the Aristotelian sense. And atomic logic from perplex number theory, graph theory, and Charles Saunders Peirce's semiotic theory of logic. The grounding, the logical background for this comes from studies basically of Charles Saunders Peirce's semiosis, published in the mainly between 1880 and 1910, where his notion of logic was developed, quite different from the logic of Bertrand Russell and other notions of symbolic logic. And so that is a distinction I want to make between axiomatic logics derived from Russell's notions and others, from the chemical logic that Charles Saunders Peirce developed. So logical particles is a term I will use that to denote, construct, and relate the mathematics of the physics of the table of elements. So the table of elements is going to be the self-referential form of which I will start with. The table of elements and the physics of the table of elements will be the referential forms from which I will start. So the purpose of hylomorphic logic is to create semiologic, self-referential notions between signs and symbols that are used in the sciences. And the particular purpose for this was developed in the sense of what is known in pharmacology and toxicology as dose-response relationships, and these are critical to the evaluation of the safety and health of drugs, for example, and then for the relative risk involved with toxicological consequences of environmental pollutants. So these are very pragmatic reasons for developing this. My concerns have never been to somehow squeeze life into a physical axiomatic form of being. That notion is just foreign to my character. I think physics and mathematics, or physical notions and laws, are very, very useful for describing systems, particularly dead systems. They have some relevance to living systems, but that relevance must be very carefully titrated to distinguish between when you're dealing with axiomatic systems versus relying upon the demonstrations that you can observe in the clinics or in the laboratory. That is, what I'm trying to distinguish here is between those observations and meanings which are intrinsic to living systems, as opposed to those observations and meanings which are described by physical notations of mass and energy. So this distinction I'm trying to make as sharp and clear as I can for you in your own minds. So the symbolic notations represent the structures of electromagnetic constituents and for the quanta of life, as well as the thermodynamics of life and the logical terms of molecules. And so the logic that is being developed is consistent with structural thermodynamics that occur during life, growth, and reproduction of organic systems. Oops. Apple's doing it to me again. The challenges for the logician is to put the hylomorphic cybernetics as a form of reasoning that relates the ascription of systems to the descriptions of systems, as well as the self-referential circumscriptions of life that are intrinsic to the life cycle of the organism. So this is what I mean by semiosis, and parts of the meaning of the notion of semiotics is when you ascribe properties and characteristics to living systems. And then as a consequence of logic, you end up with mathematical descriptions of what you have observed. The entire process is cyclic, and that's a whole lecture in itself about cognition, how you relate ascriptive terms to descriptive terms to the circumscriptions of systems, particularly cybernetic circumscriptions of the systems. So the references in our semiotic analysis is based on references of exact logical particles for the natural reasoning, and this I've already talked about. So this is an overview of the general notion of atoms to anatomy. This is an ascriptive description, or prescription, I should say, of the relationships of semio-cybernetics. The anatomy of the whole can be related to the atomic parts of the whole. Those relationships between the anatomy of the whole and the atomic parts of the whole are developed systematically by decomposition of anatomy. And this goes back to Galen, who started this notion of description of the internal functions of an organ. And of course, molecular biology in the last half century has pushed Galen's notion of anatomy down to the atomic level. From a mathematical side of things, the atoms of the decomposition are they form a permutation group of atomic numbers. And so that's the crucial logical connection here, is the permutation group of atomic numbers can be derived from the anatomy of any organism systematically. The corresponding part of the cybernetic cycle here is composition of atoms as parts into the anatomy of the whole again. So this part is obviously the difficult part to describe. The cybernetic composition is terms of the number of system descriptions, which is in the first column on the right. You need ascriptions of the composition that you have developed from decomposition in terms of basic numbers. It's described in units of meaning, and these two are related then by permutation groups and space groups. And I cannot take the whole issue of how you relate permutation groups to space groups is a mathematical problem, which I will not describe here at all, but it is vital to understanding what I mean and the formalisms involved. In terms of semantics, you ascribe to any anatomy names and sentences and grammars of relationships among the parts of the whole. The terms, as I meant, that are used, logical terms are elements, that is, elements of meaning, compounds, constituents, cells, species, organisms, etc. As you have developed from the decomposition of the anatomy. The formal transformative relationships are logical in nature. These are logical in the sense that they relate mathematical objects to one another, and the Latin notion of the word ducere, that is to lead to, is what grounds the relations and the references between the logical sentences that are used in the grammars that are used to describe the decompositions and recompositions. The formations involved, transformative relationships, can be expressed in a variety of terms necessary. Now, moving on. So how do we relate all of these parts of the whole from a practical side of things? We depend on material demonstrations, exhibitions, and attributes of the organic forms that we've assigned qualitative and quantitative names, forms, formulas, formulations, as appropriate to the system we're describing and what we're trying to describe. Secondly, collections of the ascribed systems as logical particles are conscribed into internal cognitive forms. That is, we form a mental image within our minds of what we are interpreting from the signs of nature. So the natural observations, in some way, we represent these in our minds as cognitive objects or as logical particles that then are used to do logical operations, transform into other objects. So this, what I've been trying to put into words here, is the notion that we develop a locative logic within our minds where we place different cognitive forms. I can't hear you. There's some noise in the background.
No, she's muted. No problem. Please go
Okay.
on.
So this notion of a locative logic is what I'm trying to put into words here. A locative logic that locates the parts of the whole into specific relationships in a pattern with one another. That is such as what in mathematics is called a graph, or a graph basis for it. Now, this graph is formed from atomic numbers or some compositions of atomic numbers. The syntactical terms and sentences are cognitively constructed from our pictures in our minds we have of the organization of the parts of the whole. And these cohere with the denotative forms emerging from the representation. So this point is the transformation in our minds of a picture of a pattern into syntactical terms that relate the pieces and parts of the representation. In the language of semiotics, this process is called semiosis, and this again forms another complete lecture separate and independent from what I'm speaking of, not independent, separate from what I'm talking about today. The notion of semic terms are the names, and the forms are described, and the semantics words are expressed in terms of the causal relationships, the material causal relationships among the relatives that are given by the forms. Don't let my cat bother you. She's always a nuisance. Semiologic, now we want to move to how do we do this from a philosophical point of view. We need an epistemology and an ontology that bind the parts of the whole together. And to this, I go back to Aristotelian concepts of taxonomies and to Aristotelian concepts of causality. So the for the necessity to retreat several millennia backwards to get away from the profound influences of the terminology, modern philosophy of science, basically, is absolutely essential to this description. And then, that's, again, another topic for a long discussion. But so Aristotelian taxonomies, Aristotle put together 10 notions for common terms of descriptions. And the one I want to, these are listed on the left, and I would point out on three of them that are of great importance for the logic involved in hylocybernetics. The first is that of relatives. Within axiological relatives, we can associate numbers without the notion of a variable, without introducing the notion of a variable. And so the notion here is that, from the foundational perspective, is that the atomic numbers are a set of relatives that can be used to form cybernetic systems from. The action and passion and time and place are what must be referred to in order to develop the patterns of mathematics that I described, are somehow, somewhere, and some way, and some time and some place. So what I meant by locative logic is related to the notion of action and passion, time and place. And this is something that, if you're doing typical systems theory, linear systems theory in mathematics, you have to put all of these into the initial conditions for the differential equations. Here, these terms are developed from the relatives rather than from the initial conditions for differential equations. The other term I would point out is disposition. Disposition here is a sense of placing things into a logical pattern, placing the terms into a logical pattern that would be described in terms of graph theory. In terms of categories, Aristotle put together 4 forms that are widely described in various philosophical descriptions of science: formal, material, efficient, and final. This notion here that then I would separate out the approach of semio-cybernetics is to material causes with species and identities of species versus efficient causality of axiomatic systems where motion and processes involving mass and energy are of the primary concern. And the final causes is also widely described, and that's beyond the scope of this lecture. But the distinction here is that the logic of semio-cybernetics places first priority on material descriptions of systems, followed by the introduction of efficient causes in terms of motions and time and energy. So how do we make these two things consistent with one another? These axiological systems versus axiomatic systems. How can we do this in a systematic way? I developed how to do this independently over a period of decades and had a very long, convoluted arguments involved that Gerard has endured for several decades. But and Pedro also has seen the background of this. But the critical conceptual change originated in a paper by Solomon Pfefferman which I discovered a couple years ago, where he clearly labeled what he called 10 theses of ontologically non-realistic philosophy of mathematics. And I highly recommend this paper to anyone interested. It's available on his website at Stanford University. He is a well-known philosopher of mathematics. So he put together 10 theses that he just set out to describe the logic of mathematics. And this, if you're familiar with structural mathematics and the development of the history of philosophy of mathematics, this paper turns the philosophy of mathematics on its head. And it is really, if you're going to read it and study it, give yourself a year or so, because it's it's a challenge. So the basic objects of mathematical thought exist only as mental conceptions in the processes of counting, ordering, matching, combining, separating, and locating in space and time. So for him, these are what Whitehead would refer to as terms of process philosophy. These are processes of counting, processes of ordering, processes of matching. If you're talking about vector systems or topological systems or whatever, these are all questions of combining and separating. And note here particularly the words combining and separating come directly from Aristotelian text with regard to his 10 categories. So that the distinction here is that mathematical thought as mental conceptions as opposed to being physical objects. So the general ideas of order, succession, collection, relation, and rules and operations are pre-mathematical. Order, succession, collection, relation, rules, and operations are pre-mathematical. That is, you must have a mental conception of these prior to understanding mathematics. A semiotic and a semantic basis, as opposed to something relying on axiomatic rules, such as set theory, or vector theory, or category theory. The general idea of property is pre-logical. Some implicit understandings of that and of the logical particles is also a prerequisite. So he's talking about prerequisites to mathematics, semantic prerequisites to mathematics that require understanding of logical particles. And then he describes the objectivity of mathematics, not in terms of mathematical objects, which is what the usual philosophy of mathematics is, but he relies upon stability and coherence of repeated communications, critical scrutiny, and expansion, or extension, I would use the word here. The objectivity is a special case of intersubjective objectivity that is ubiquitous. Now, in other words, he's saying we're not talking here about universal truths in the way that is so commonly used in axiomatic and philosophical renditions of mathematics. So how does this relate to semio-cybernetics? On point 8 and point 9, first of all, the table of elements is a table of the ordering of the elements and of the numerical succession of elements. And the table of elements is a collection of elements. And the table of elements is a relation among all the elements. And then the basic rules of combining objects of the table of elements are, and the general term is used, valence of the individual elements. And each of these individual elements has a different valence meaning in terms of forming relations. as far as the general idea of properties, is pre-logical. That is, each chemical element is given an identity on the basis of its properties, so that the properties are prerequisite to the name of the element. The name of the element has as a prerequisite its general properties that have been identified by demonstration in the laboratory, by isolation and separation of its identity from all other elements. That is, a chemical element is an independent logical object. And that independent logical object is a logical constant. And it's a logical constant in the sense, from a scientific point of view, because it's based on a specific set of properties that give its identity. So this leads us to our general conclusions about how we describe a realistic philosophy of self-referential identities based on electromagnetic properties, demonstrations, and exhibits. The consistency of hylomorphic operations is derived from self-referential physical consistency that is entailed from the inverse square laws of Newton and Coulomb, and the self-referential biochemical consistency of the addition of logical constants. The addition of logical constants, all of which conserve the symbols under the laws of conservation of matter and the conservation of electricity that are described in Newton's and Coulomb's laws, is implicit to the notion of these addition of logical constants of atomic elements. And of course, in living systems, the biochemical consistency is developed from the notion of the reproduction of the organism producing the same set of logical constants in the offspring as exist in the parents. So that is the background for the consistency, in the sense of Hilbert, of the operations involved. Parenthetically, I note that Hilbert's primary criteria for mathematics was the notion of consistency. From this, we go on to three particular conclusions. The concept of logical particles is implicit to natural and human reasoning. The grammar of semiologic cognitive processes is inferred from the demonstrations, which we can describe in terms of seams, where seams is a general cognitive term describing any logical object. So seams is a mental concept. It's a notion of a logical particle that we can manipulate with our minds, much as if it was an image in our minds. And we can do arithmetic and algebra on the seams of atomic numbers. I've described this separately in the notions of the perplex number system. The important part about this is that we can use logical particles then as a basis for symbolic notations of connectable collections of relatives. And this connection of symbolic notations as connectable collections of relatives can be described in rather numerous different symbolic logics as well as scientific symbol systems. It's a question of how we decide how we connect the elements together that constructs the system from its parts. This is very abstract and difficult to comprehend in a general sense. But as a simpler example, I would put together the notion of how is a musical score constructed from individual musical notes. If a composer is to write a musical score for a symphony, some will say Brahms' Fifth Symphony or something, that is long and convoluted, somehow every note in the symphony that can be played over an hour has to be in a particular locative position in the score of the symphony, such that the musicians can read the score and play their notes in a timely manner. This example is fantastically simplified from the relative notions of the complexity of life, yet it still sort of captures the essential notions of human reasoning in terms of semiologic cognitive processes. The second point is that the general idea of number is pre-logical, pre-physical, pre-chemical, pre-biological, and pre-philosophical. Numbers are intrinsic to nature, and our ability to capture this in our overall cognitive processes is very, very difficult. The streams of reasoning that descend from numbers and which effectively involve either the singular or plural notion of terms is just profound, and particularly grammar is, of course, one simplified example of that, but it infers the information is there. The particular idea is involved with a table of elements is that the order of the table of elements, the succession of the individuals of the table of elements, the collections of, etc., are all necessary to conduct hylomorphic experiments. Necessary to connect hylomorphic experiments. Yeah, that's what we do in the chemistry laboratory or in the molecular biological laboratory or in the clinical laboratories. The semiologic proof of chemicals are premised on determining the location of the particles. That is, someone, something, somewhere, somehow, some way, are part of the mathematical diagrams of the constituents of the chemical elements and the compounds. So this is the locative logic of semio-cybernetics. And thirdly, the basic objects of the perplex mathematical thought are the hylomorphic agents of the elements as atomic numbers, so that the agency of the individual chemical elements exists as a cognitive reference for the logical particles, and these represent the processes of counting, ordering, matching, combining, separating, and locating in spaces time as related Hylic agents. In this form of reasoning, the Hylic agents here refer to atoms, molecules, etc. The common element of this form of mathematical reasoning is graph theory. In particular form of graph theory in which there are two types of particles, two types of logical particles in the graphs. The two types of logical particles are, shall we say, polar opposites in the sense of positive and negative. These two types of particles are binary in the sense that they are either nuclei or electrons. These two types of these Hylic agents are also related, as you can say, yes, it is this, or no, it is not that, with respect to its demonstrated properties. And so these combinations together form what is referred to as a labeled bipartite graph. A labeled bipartite graph is a mathematical object that was developed specifically for the purpose of description of complex systems as referential systems. And more precisely, the background for the development of bipartite graphs comes entirely from communications theory. That is, the switchboard operators. If you can go put that image in your mind, Ram, of switchboard operators plugging things in and out as being operations on a bipartite graph. And so the logical development then of semio-cybernetics comes from the notion of, one of the origins of it is the notion of communications theory in terms of connecting agents as bipartite graphs. And so that I will stop, and thank you for your attention, and we're open to questions of any sort and kind.
Thank you, Jerry. Now, Ram, are you going to talk the first one? You and the Ben are supposed to be the major responder. Still muted.
Hi, thank you, Jerry. It was a very nice talk, and I did respond to you before, and I was from your talk, what I understand is you're describing the process of language. The semio-cybernetics looks at language as it has after it has been established. So what I had been presenting is a concept of open system. How did the language itself evolve? How does a child learn a language? And then I go back into the neuronal network, which really allows the child to form its own rules by self-learning or self-organization instead of being handed over the rules. That is, it just takes the input output and forms its own rules. So we kind of we're looking at similar items, but I'm trying to model it as an open system, whereas you're looking at it as an already evolved system. Do I understand you right?
In general, yes. I concur with most of what you have written, or that I have read of what you have written and your talk. The distinctions are, and actually you've captured the fundamental distinction from how we go about doing our work quite well. Okay. The presupposition that there is an open system such that you can do development of language within it is more what I'm talking about. That you have to presuppose that there exists some open system that a language can be emplaced or embedded in. And the processes of developing that language as being semio-cybernetic images or pictures in our minds that we develop and mature and arrange the parts of the whole, and that sort of activity that are necessary to describe the emergence of language from as an open system is where you're coming from. And from a physiological point of view, I concur that that's basically the fundamentals of how things operate. So you make in your point of view, you make quite a large number of assumptions about how this open system is constructed, such that it can be capable of conducting the operations that you ascribe to it. And then give a mathematical description of what you've ascribed to that system. Okay. Yeah. So
Okay.
yeah, I think from that side of view, it's quite coherent.
Right.
The philosophical side of it is quite another matter
Right.
in terms of the roots of the philosophy that are being developed.
So that is, instead of looking at language as the graph theory, I'm saying that learning, memory, and recall, the whole process should be looked at as a bond graph theory. That means there are the two aspects. For example, at every node in a neuron, there is a conductance, and there is also a charge that is flowing through. And those are two independent things. In the bond graph theory, basically, you will specify both the current coming in and the voltage. And the current mechanism then becomes the biochemistry, and the voltage coming in becomes the electrical ions flowing through the open conductors. So it essentially, the system is self-organizing, and I talked in the last meeting about the concept of how self-organized open systems evolve. So you're looking at it after the fact, I'm saying. Okay.
Yeah. Well, Ram, yes, but now look at the language you're using in separating a bond theory from a bipartite. Okay. So you're the notion of a chemical ion is what? It's part of the table of elements. And
Right.
biochemistry is part of the table of elements. So
Right.
you have moved up a symbolic level, shall we say, in your ascriptive language to now where you're looking at very complicated, well, the size of your system is moved from not simple integers up, but in terms of number of particles involved. But 10 to the 12th, 10 to the 13th, 10 to the 14th or so particles to relate a synapse and the communication between the synapse and the cells. Well, actually, that's too small a number. It actually takes considerably smaller. Takes roughly 10 to the 16th or 10 to the 17th number of logical particles in your description to make your description work. Is that basically correct?
Maybe what I'm trying to say is the purpose of language is communication, and the communication arises when the meaning is understood and is being conveyed. And it is the meaning part that I'm saying is the association, and that has to be learned, and that process is not captured by the part of the semio-cybernetics that you're talking about. How the relationships are established. We are already saying that their rules exist and the tables have been given already.
That is only because I've described the basic foundations of semio logic.
Okay.
Okay.
Okay, thanks.
I did not go into it all, the relationship between semio-cybernetics and the notion of symbol systems. Because the symbol systems that are used in your description, in the learning of a language, you must have the notion of some form of alphabet or some set of symbols that represent sounds, that represent language. That's the constituents of the logic of language is symbols that are communicated from one person to another. And these are, as you point out, these are evolved systems that have that. That does not mean that the logic, semio-logic aspects of it or cybernetic conceptualization of it is fundamentally different from what I have described. It just says you are looking at now a much larger symbol system, a radically different conceptualization or cognition of the symbol system that you're describing the relationships between.
Right.
So I did not go into the hierarchy of symbol systems and how the hierarchy of symbol systems is related to communication. And so, yes, I think we concur quite well. Just that because of time and space and limitations, I had to be precise and concise.
Right.
And the other way is that to unpack all of this, it requires a book to do it. And that's what I'm
Okay.
working on, obviously.
Thank you.
Yeah.
Bang,
Can
Bang, are you there?
Jason, do you mind if I
Yeah, if Bang is not here, go ahead.
yeah, thanks.
He's not here. Okay.
Jerry, what a beautiful presentation. Thank you so much. And Ram, thank you too for your contribution and curiosity about language and children who are process philosophers. And the bridge here, I feel, so my background is 20 years of kindergarten through 12th grade, language education, working with children from diverse language and culture backgrounds in all kinds of school environments. And Jerry, what I think the bridge here is that language learning is contextual, and the contextual relationships are really what guides a very nonlinear progression. So just like systems, everything is relational. And then you have these unique characteristics that are, non-representational. I think, that's why I like Whitehead so much. And that's why so many Waldorf teachers and anthroposophy recognizes the process of being in a universe like this one. But my question is, a while ago, you and I were in the Club of Remy knot theory discussion, and I have a particular interest in figure eights, and I feel them. And so yesterday I chatted with you and I talked about how I drew this figure eight of math and language. So my question is related to this. In Waldorf classrooms, the order of operations of math is different and introduced differently than in the public schools I worked in. In public schools, we teach addition and subtraction. In Waldorf schools, they start with division and they make it very real during snack time at the table, where they have a certain number of snacks and certain number of children and they group. So I'm wondering, to bridge this idea of contextual relationship and language and math as symbols that are poor descriptors eventually of the experience and the context. Do you have any thoughts as we think about bringing systems education to more awareness in education? Do you have any thoughts about bridging these worlds beginning in
Yes.
elementary?
Very, very curious question, Lisa, and really well posed because it gets sort of to the essence of descriptions and how you go about learning descriptions. So I would point, the question is where to start the answer from. From Aristotle's notion of categories, he had two notions, one of separation of terms, logical terms, semantic terms, basically, and the other of combination of semantic terms. And these two things are opposing operations. And so which one you decide to start with was amply demonstrated in the slide that I showed with regard to the arrows going up and the arrows going down. The fact that it's probably easier to visualize separation of two things as it is opposed to combining two things. And certainly linguistically, this comes to be a crucial element of the distinction of the languages of physics from the languages of chemistry and applied chemistry, biological sciences, in other words. In the language of physics, the notion is that you start with a variable representing things, and then you add or multiply operations on the variable to create a different object. As compared to the object of chemistry, you start with something like sodium chloride, and you divide it into two parts, sodium as an ion and chlorine as an ion, and then if you combine these two ions, you get sodium chloride. Both of these now are composites of the element of sodium and the element of chlorine. Notice a little difference in distinction of terminology there. Of when you describe a molecule, and this is back to Russell's notion of atomic sentences versus molecular sentences. Atomic sentences have properties associated with one. And so if you start with the notion of division, you're starting with the notion I can divide whatever it is that I have into something else. I can divide it into at least two other things. And if you want to combine them, then you have to do the other operation. You say, I have two items and I'm going to combine them. And obviously, if you start from simple notion of addition as being foundational to the logic, then division becomes secondary.
Yeah, you know, just to follow up, I'm remembering, so one of my teachers is Fritjof Capra, and he talks really from the very beginning about the quality of cellular in creation, that one end is hydrophilic and one is hydrophobic. So the very origin of creation is from this opposition. So I guess we're not going to solve it.
No,
Heiner, you raised your hand.
Well, could you just let Jerry respond, please?
oh, that is an interesting part that goes far deeper than hydrophilic and hydrophobic or the other terms that chemistry uses that are intrinsic to emotions. Obviously, hydrophilic means to love one another, and hydrophobic means to hate one another. And the same notion with nucleophilic and electrophilic. These are notions of opposition, polar opposites in meaning. And this is what stumped me for decades of how do you resolve this conflict? And the way that chemistry is resolved in the logic of chemistry is to one hand use a singular term for the notion of the object and then describe its parts in terms of polar opposites, that is negative and positive charges. And so the conflict there is deep within nature. It's not just within languaging or a particular way. It's the fundamental nature of choice that you must make if you're going to describe the dynamics of systems. Now, the other part which is important is that, in this short notice, a short lecture presentation, the entire grounding of, I shouldn't say the entire, the critical understanding that comes for the development here is the necessity to relate the environment to the organism. Now, I did not develop this argument at all in this short presentation, but it is absolutely essential. And this is part of what Ram's concerns are about. But you have to logically in your mind make a cognitive distinction between the organism as a system and how it operates in contrast to the relationship of the real world where the system is embedded in an environment, the organism in its ecology, such that you can describe the dynamics of the system and you can then enable biological reproduction. I didn't discuss this aspect of it all. But
Okay.
the biological reproduction part was essential to the development of the argument.
Jerry, as the French say, vive la différence.
Yeah, genau gesagt auf Deutsch.
Heiner, you're muted. Click the microphone
Space.
button to unmute yourself.
You press the space bar.
Maybe no.
Oh, yes.
Okay. Yes.
Jerry, I'm thrilled and I'm very happy that I'm here. I mentioned in the chat that we with the ISSS Wholeness Seminar Primer Group 30 years ago did this Wholeness Seminar, and there your thing when we did a third edition would fit in. And there we have a special section, Wholeness for Kids. So I'm also very thrilled with what Lisa said. And our response, what we are working on, is going to kindergarten and add to system thinking, model thinking. It was developed about the same time. But what I wanted to say to Jerry, this adding additionally or expansion, you said, of symbol systems and the relational contextual dimensions to that really caught my interest. I hope I just referred with Peter Sutherland, who was the former president of ISSS, that we really very soon expand this old thinking to an expanded thinking, what I experienced here. And maybe a note also for Lisa. We are in a group with Jeremy Lent, Club of Rome, on highest level on Earth survival and everything. We were together yesterday, and on Sunday, we have a session with Fritjof Capra. And I was with him also in the early 70s already. So I think it would be very nice to stay in touch. I have to rush out. I'm here in a public library, but I might be able to listen in. Thank you.
I would just make a comment here. Yeah, I did give a presentation to the ISSS in June, I guess, and the logic has developed furthermore. But no, with regard to the hierarchical construction of symbol systems, again, this is something I've spent an enormous amount of time on. Another lecture could be is necessary to describe the intricacies involved in the sense of sort of compiling symbol systems. There is a notion of superpositioning that is necessary. And that superpositioning of symbol systems requires far deeper inspection and descriptions of both the logic and the mathematics, because you're now moving into a different sort of languaging about how you're thinking about the system. And the simple notions of semiosis that I used for description here become far more complicated, as you necessarily must relate, shall we say, multiple systems of thought into an organized whole, a complete whole, something that actually communicates to another mind. And this is crucial, that actually communicates to another mind the track of reasoning that you are using to go from the antecedents to the consequences. And this aspect of it, again, it's rich, it's fulfilling, it's fun, I'm enjoying life. Take it from there.
Yeah, the lecture with Fritjof and Jeremy is on my calendar for Sunday. Thank you, Heiner. I think it's also really interesting to think about like I'm really interested in developing an oceans literacy curriculum, and I know that's where Peter's work is also. But I'm being guided toward other ways of knowing that are present in ocean life. Yeah.
Jerry, I have two questions.
Sure.
One is my feeling that your work is pushing one extreme of constructivism back to a more balanced point. What I'm saying is Heinz von Forster's work is pushed to the point that they claim the reality, the whole reality, is coming from your dream. So my understanding is your work with the chemistry and with the symbols are pushing that view back a little bit to the more balanced area. There's something not that dreamful that we need to pay attention. So I don't know how would you compare your work with the group of second-order cyberneticians. That's one question. Second question is from my curiosity is you said this work has been long years you have been
Jason,
developing.
Jason, could you hold your second question? Let me respond to the first one.
Oh, okay. Go ahead.
Because my mind was moving very rapidly as you went through the first question. I don't want to lose the trail of tracking the thoughts. First of all, as I mentioned at the very beginning, this project originated in 1971. Well, yeah, in 1971 was the original thoughts about how this notion of a biological mutation could be described as a single unitary event. In other words, it was incomprehensible, totally incomprehensible to me that a single atomic event at the level of, given that there are 10 to the 23rd atoms per mole of atom, so that a tablespoon of water contains 10 to the 23rd molecules of water. And so it was incomprehensible to me how one molecule of a mutagen could mutate a cell and change the entire cell. And that's really what a biological mutation is in terms of DNA, in terms of genetic interpretations of that. And so you need this enormous amplificative logic to move from the level of atoms to the organism as a whole. And now my original reasoning concerned the simple bacterial cell E. coli. But in fact, there are an enormous number of human diseases that are directly related to single base replacements in human DNA. So there's a necessity for an amplificative logic that changes the notion of an organism from a change in a single base to a change of the entire organism, and that this requires basically a process of expansion or extension of the logic, roughly 10 to the 28th orders of magnitude. Now that's a pretty big number. And so this is where the distinction between constructive mathematics and, shall we say, classical Descartesian mathematics comes into being. That the constructive mathematics acknowledges this process of construction as going stepwise from one term to another term to another term. And the notion of variables as it's used in the normal Descartes or Pythagorean notion of mathematics starts with a complete set of whole numbers, or real numbers, excuse me. In other words, an infinite number of things, and then selects individuals on the basis of the relationship between the domain and the range. And in this cognitive activity of saying that there is a rule that combines everything from the domain with something in the range is where the distinctions come in between constructive mathematics and that. So that, and geometric mathematics, if you want to put it that way. The necessity of using constructive mathematics is fundamental to starting my set of arguments with the table of elements. In other words, with logical particles. So when I say logical particles, it can mean anything of any size, from electrons and nuclei to populations. It's a question of how you cognitively address the meaning of a particle. You can either do it geometrically in terms of domain and range of classical mathematics, of particularly of categories of topological spaces, vector spaces. There's a whole long list of mathematical structures which are concerned with how you establish rules between the domain and the range. And these are for real number systems, for infinite number of numbers, these rules apply. Well, my approach is quite the opposite. Okay, and this is where von Foster's, the distinction that you wish to make, Jason, between von Foster's notions and first order cybernetics come to play. I'm saying there's a mapping between what I'd call third order cybernetics that accomplishes the task of going from first order cybernetics to second order cybernetics.
There is just one point. I was saying in the stepwise, instead of using arithmetic progression, if you use geometric progression, then the scaling becomes really horrendous in no time because it's an exponential process. And I was saying that the geometric ratio, if started with golden ratio, that appears to be a ubiquitous universal process. And in no time, you can go from one atom to the cosmic level because it's to the power of n.
Yeah,
right.
Yeah, that's why I responded so strongly when you introduced the notion of the ratio. If you recall your presentation, it just made my whole body respond because of the very reason you said. And of course, if you're going to go do geometric ratios, then you cannot maintain your logic in terms of addition and the conservation of matter and the conservation of charge.
Right. But that is where the concept of self-organized system, emergent phenomena, it is not addition, it is emergence.
Well, but you cannot, because it is
criticality things emerge.
say that
Right.
it is
not
not addition.
Pardon?
The conclusion that emergence eliminates the possibility of it simply being addition, I think is not justified.
No.
They're just different symbols.
Addition is the simplest form of emergence, right?
Huge area of work between your two.
Go ahead. Yeah.
Can I?
I mean, there's a huge area of work coordination between your two perspectives. My second question is already partly answered by Jerry already. I was trying to figure out before you decided to do this research, going into this rabbit hole, what was the problem that you were burning to resolve? I mean, what was kind of the thing that pushed you? You sort of partially mentioned that, but maybe I'm not right. What was the problem you was trying to resolve before you started getting into this?
I suppose my problem is that I love to read books. That's the problem. I'd like to have a coherent view of the world. And that, I mean, I can put it into broad philosophical terms of my personal values. my particular obstinance in terms of pursuing arguments to wherever they go. Or I could describe this in quite a number of ways. But Jason, the foundational scientific questions arose from two parts. The first one came out during my work, as I pointed out at the very beginning, of studying metabolism in the organism E. coli and the genetic regulation. My problem was to determine the steps in the pathway of the synthesis of a specific molecule, starting from the known elements of the cell. In other words, we knew this molecule existed in the cell. We could analyze it. We could determine its amounts. We knew much of its functions in the cell, but we didn't know how the cell made it. And so we had to start with simpler parts and pieces of basically from the Krebs cycle or from the Krebs cycle and glycolysis and construct this new molecule. So it was an effort to combine two or more parts to make a single part within the cell. And now this is, these are talking about now very specific energy, very specific objects. We can give names to these objects, we give molecular formula to these objects, etc. So that we have quantitation of the meaning of these constituents. We just didn't know how they were made. And so we knew that the cell must have enzymes which would make the conversion of the parts into the whole. Okay, this is what metabolism is all about. Okay, basically is the construction of the self, the self-referential self from the world, the outside world. Okay, so that problem turned out that I spent my entire thesis do it, and I couldn't solve it. And the reason I couldn't solve it is because there was, how could it be? Well, basically the basic reasons was that the dynamics were very unusual, highly unusual dynamics. But in addition to that, there was the problem of regulation of how this worked. In my search for this question, there was a pathway. I was able to determine that there was 3 different classes of genetic mutations which contributed to the metabolic pathway. And so the simple logic was 1, 2, 3 steps. 3 genetic mutations, okay, 1, 2, 3 steps. Well, it turned out that basically 2 of them, the genetic mutations were relevant. The third one was effectively cybernetic in that it was a regulatory mutation which regulated the other 2 genes. And not only that, it regulated several other genes involved. And the effective solution to that problem came 30 years later from another laboratory when they identified exactly how this third gene was functioning. Okay, so that hunger for understanding of how living systems worked was grounded in those PhD theses in the 60s, all right? So that's point 1. The second one is very intimately related to it, and that is the question of, given a dose of any chemical to any organism, the organism must respond to it. And how the organism responds to it. And this is a material argument, Jason. It's not a conceptual argument in its usual sense. It's a material argument. If you take hydrogen cyanide, you're probably going to die. And there's a particular reason why you will die from hydrogen cyanide, and that is because it blocks oxygen transmission through hemoglobin. It binds to hemoglobin and does it. This is a dose-response relationship. Extremely small amounts of cyanide will kill you. in terms of other toxins and yeah, now just as an aside, for several years I served on the National Academy of Sciences Committee for the destruction of chemical weapons. And so I became quite familiar with neurotoxins and the extreme specificity of neurotoxins and their extreme potencies, in which picogram quantities of a neurotoxin would kill an enemy soldier.
Yeah.
Picogram quantities. And so this dose response is one extreme. On the other extreme, you know, you can probably have a better part of 30 or 40 grams of sodium chloride before it would kill you. There's other, you know, there's things that are very non-toxic. So the range of toxicity of different molecules is over many orders of magnitude. And that request then leads you to consider what are the relations between the structures such that this is so extremely toxic and this is relatively non-toxic. And so that then is a situational logic that how you view the relationship between these structures determines what your conclusions are, what your cognitive imagination is with regard to the relationships. But this requires a different notion of relationship than classical mathematics of domains and ranges. It requires that you consider the structure of the chemical as well and the structure of the organism. You must require both structures. And so it's not possible to have a coherent theory, a coherent logic, without considering both. And so you're then forced into a binary logic, a communicative logic, an informative logic, however you want to, a cybernetic logic, whatever, however you want to classify this necessity for having two being combined into one. Is that helpful?
So we can tell hands from first the reality could be a dream, but it has to be a correct dream, not a wrong dream, right? So there are good dreams and bad dreams, correct dreams and wrong dreams.
Yeah, I mean, the question is your notion of how you want to conceptualize the truth of dreams. The logicians and philosophers look at the term notion of dream in terms of truth dream or false dreams, in terms of coherent theories of relationships or corresponding relationships between the elements of truth. Okay, so that the correspondence is radically different from the von Foster's was a coherent sort of perspective, opposed to a correspondence one. Not that either of them are in the ultimate language use correct or incorrect. But the way to solve this problem, not to solve it, to avoid this issue, then is to recognize that with the demonstrations that you make in experimental situations, you allow that to be the decisive factor. That determines your categories. That determines the relations and not abstract theories.
Thank you. Carol, you want to say something? Lauren? Delia? You haven't said anything yet.
Oh, no, I haven't said anything. Hi, everyone. Yeah, look, thank you so much for for an interesting presentation. And I've got to say, a couple of things have actually come up through the discussion. And Jerry, I just wanted to sort of clarify before I continue, but it almost felt like you were trying to, and Lisa, trying to resolve these seemingly two opposing conditions or states that systems have. And I sort of, in my work, my appreciation is that we actually need this seeming paradox in order for us to grow and learn and maintain a system so that it doesn't scale out of control. In a system sense, that paradox is required in order to control the system, so that goes, one way or another. So I guess my question would be, like, why does it need to be resolved? I just wanted to understand why it needed to be resolved.
This follows very directly from what Jason's questions were. The issue that came to mind much later in my own thinking, actually probably 3 decades later, in the early 90s, was the question of how is it even possible that life exists? How is it even possible if you start from some logical perspective or any sort of perspective? You still are left with the problem of how to explain that it exists. And this, of course, was part of what was going on, or come out from not the sciences per se, but from the philosophical discussions among physicists and engineers of what they call complexity theory. And what might be complexity theory, which developed starting in the late 1960s with regard to chaos theory and corresponding other developments of nonlinear, what they call nonlinear mathematics.
Santa Fe's work.
Pardon?
This is mostly in Santa Fe Institute. They do a lot of computer stuff there.
Well, yeah, computer science is involved. A number of prominent mathematicians were involved. And I happen to become close friends with one of the mathematicians involved. But the whole idea of what is the relationship between science or nature and life, such that life can continue to reproduce itself. And in order for life to reproduce itself, it has to remake all of its parts. So when one cell goes to 2 cells, the new cell has all the same parts as the old cell, the parent cell. And that's the fundamental, simple to observe demonstration of the nature of life is reproduction. And it's a categorical distinction between living systems and dead systems.
And so how would you see your work as related with Monterano's work in terms of similarities and differences?
That's a longer question. Let me finish her question first, and then
Okay.
So the issue then becomes, how does all this become? You can demonstrate in the laboratory enzymatic processes for all of these conversions effectively. And at the time, we could only do a few of them. At the time we do for E. coli, at the time we could only do a few hundred, and now we can do a few thousand. So we know about 98% or more of the reactions that go on in E. coli, and that these are necessary for the reproductive aspects, for the cell to reproduce itself and to generate an identical offspring. And the crucial word here is an identical offspring because of genetics. How do you do that? And the question becomes back then to, well, it's a completely generative system that generates new information that is tightly regulated or controlled, or in semiotics, the cybernetic cycles that are associated with every molecule in the cell. Cybernetic cycles which are associated with every molecule in the cell, whether it be the roughly 5,000 molecules in an E. coli cell that are reproduced from parent to offspring, or in the case of human beings, where we have maybe 10 to the 15th cells or so. Each of the constituents of those molecules that we know for human beings, we probably have roughly 5 to 10 million different molecules in our cells. 5 to 10 million. Every one of those is involved in a cybernetic cycle. Every one must be, or it could not be reproduced. Does that make sense to you?
Yes.
Yes, thank you.
Can I also say that, Delia, for me, so much of it is accompanying. So like Jerry, I'm a very eclectic learner. And so for me, a lot of it is about sense making and helping learners make sense of their understanding, experience, difference. But it goes back, Jason, actually, to your first question. I'm thinking, for some reason, that not theory, Club of Remy, one of them, I guess, was really memorable for me because I think there was a lot of emotionality in that session. There was, that's why it's memorable to me. But I remember your question was actually about mutation in that one too. So I'm interested in knot theory because it is about relationships rather than categories so much for me. I think about it in terms of relationship. And you asked about mutation in that lecture. And I recently was speaking to an oncological nurse who was explaining why radiation is important because all it takes is one cell, one cancer cell, which is, we're learning like a virus, right? There are naturally occurring viruses in the human body as a precondition, and what might trip the switch to be a mutation or lose sense of the host. She said, oh, well, we don't have the diagnostic equipment to find one cancer cell. We have to find them in clusters. Well, since then, I talked to someone who said, you know, that's not really true. So I'm kind of curious, related to your question, like in living systems, where there are viruses which, you know, take advantage of the host to the host's detriment. Jerry, I'm kind of curious about, you know, how your thinking bridges this kind of older view of description in science and research, and what that might mean for how we understand in current day of the imbalance in environment when you talk about forever chemicals and things like that. Have you gotten any thoughts or inkling about making sense of where we go from here or how we go down together better? That sounds so dystopic. I'm sorry.
Oh, relates back to the question of the stability of systems and the previous questions of Doria. And things that are very much deeply interested to Ram as well in his work. So when is a system stable? When does it continue on indefinitely? And when is it unstable? And when does it change? The word mutation means change. That's its roots. That's its meaning. Its particular meaning in the case of living systems and the use of the notion of mutation in biology, of course, is highly specific and related to genetics. And separating these two meanings is linguistically a challenge in the sense of the terminology involved. Because in one case, a change in a stable system simply means normal behavior of a stable system as the parts a machine keeps moving. Change in an engine, an automobile engine, can be continuous. It continually cycles around. And the same way with normal reproduction of living systems. Generation after generation after generation is generated. And of course, with simple organisms like viruses or bacteria, you can conduct as many generations as you have time for in the laboratory. In other words, you can conduct basically experiments with millions of generations, as opposed to the normal human notion of a generation cycle. So we're talking about this time, how time is constructed within systems. And in the case of cancer, it's very, very complicated. I worked for the National Cancer Institute for several years and published a paper on dose-response relationships in cancer. But since that time, trying to convert all of the factors that are involved into simple linguistic sentences for a novice requires a lot of education on terminology. And here's not the place to do it. We can discuss that offline or whatever. But the fundamental aspect here that is behind several of the questions is the notions, particularly coming from physics and engineering, are that somehow everything in the real world is simple. You can have simple equations to describe processes, and those processes get the job done. They're adequate to make the automobile or engine or to fly the jet plane or whatever. They're relatively few processes, and they're relatively simple that you can describe in a relatively simple language. And yeah, it works great. If the system works, it works great. And hey, we're working, a huge group of people are enjoying a conversation, even though we're on different continents, in different cities, with different computer systems, with different mindsets. This is all made possible by our knowledge of physics and engineering. So we don't want to destroy that. That is a valid logic. We just want to understand how living systems are able to reproduce and have all the characteristics that we have. And so I hope that's partially a philosophical answer, but it's...
Yeah, let's hear from Charles. Charles is going to be very sleepy, so before you leave, please bring your viewpoints to us.
Thank you, Jason. Yes, it's really true that because at my
closer to 12
almost,
midnight to you.
Yes,
right?
yes, around midnight, very
Okay.
yes, around midnight time. So, and actually, I'm going to attend the 2 whole days conference. Okay, very soon, in 8 hours later. Actually, I'm now not in Hong Kong, and I'm originally coming from Hong Kong, but now at that time, I'm now in Bangkok, Thailand. Anyway, let me go back to my response. Actually, why I come across this web here, just because of Jason, who, yes, thanks again, Jason, for your invitation to let me as a non-lectural scientist. Actually, my background is social work, and my PhD is regarding how to translate or to transport some social policy or social program from one place to the another, in which I have to engage with those different stakeholders to help them to buy in what I would like to promote. So I think what Jerry shared tonight is really stimulating, could we call, or at the same time able to synchronize with what I have been thinking about to promote the utilization of some knowledge that seem to be quite well established from original place, and then we would like to diffuse to the another places. Of course, in my own fields, not my own fields, in the fields of social sciences, actually we have our own language, we have our own system of thinking regarding how to do what I have mentioned. But anyway, I think tonight, from what Jerry shared, could we be able to stimulate my thinking further, a possibility how the natural science and social science could something able to link up furthermore. In short, in my practice, I yes, never to talk about atom or the or the cell, but we would like to use the term stakeholder to describe at the more materialistic or at the more low level how those individuals able to collaborate with each other so as to promote a systemic change. And I think cybernetic, especially particularly the second order cybernetics does matter for what I'm now doing or what I'm interested in. And in short, I think how we could facilitate those, not only the powerless or the power holder to have a dialogue with each other is something essential, but at the same time, and actually it is what I'm now trying to do, is how to foster both power holder and those powerless. It is my metaphor, a very simplified classification to divide those stakeholders into two different categories. How those power holder and the powerless people able to, at the same time, to recognize, to realize, respectively, what they are being ignored or regret. Only by recognizing both parties have such kind of what I call the awareness, maybe we could really eventually to align them all together to build a holistic system for social innovation, rather than just stick to our dualism or confrontative, okay, pattern or system, just able to witness the conflict, the confrontation between these two types of stakeholders. So just like what Jerry has said before, what I'm now going to, what I'm now talking is regarding, we are not trying to destroy or anything, but we would like to observe, to understand a system, or maybe we really would like to, at least for me, I would like to support a better systemic development of a system, rather than just stick to either the power holder or the powerless people. Of course, my training is more, have a bias, tends to be supporting the powerless peoples, according to some concept like social justice. But being a system thinker, or if I would like to make use of, utilize the conception of cybernetic, especially the second order one, I think how we could build a holistic system between the power holder and the powerless people all together to make a true real change or innovation should be something that I have been reaffirmed again from what Jerry have talked tonight, today anyway. Thanks a lot. Yeah, that's what I would like to say, Jason.
Jerry?
Thank you for the comment. I would just say that I've spent quite a bit of being a public health service officer and working in the Institutes for Health of Human. I'm very familiar with the issues you bring to fore. I think you need a new language in part. The limitations, the mathematical, particular limitations of what I've described are profound when you come to respect of social systems. And I do participate regularly in a group called the Design of Government Forum, where we deal with the issues that you are keenly interested in. It's a very, very difficult issue to try and resolve. Because these are human systems and they have their rules of development from a cultural basis, not from from a cultural basis, leave it at that. So thank you for your comments.
Lauren?
Yeah, I just thought I'd make a brief comment as a first-time listener or participant here. I do cognitive modeling, so I've been looking at different ways of thinking and how they interact. So I've been listening a lot at a meta level, at the high level, and it's interesting what questions are being asked and what approaches are being used in terms of, okay, why are people being mentally driven to ask these sorts of questions and take these approaches? Like, for example, the social justice approach, or the social interaction approach, or the semiotic approach. So it's been interesting at a meta level for me.
Those are profound issues. It is only within recent weeks or recent months that I have made significant progress in understanding the cognitive issues that separate symbol systems and the role of memory in separating symbol systems, and the necessity of the communicators, if they do not have access to the same symbolic memories, in other words, they don't have access to the relationship, say, between the cell and the individual cell and the body, the physiology, shall we say. If you don't have access to that language because you have learned that language, then you can't really communicate about that language. And this is the role of conversation. You can't converse about, it's very similar to put a Chinese and a Russian in the same room, and the English observer who speaks neither Russian nor Chinese is not going to get much information from that conversation. That is how profound these semiotic separations are in the mind. That the cognitive capabilities that we must develop in order to communicate are so profoundly different from one another. And this is what's tied up in Ram's, in my understanding of Ram's interest in how language develops. We, as a group, we can communicate, but we can communicate only insofar as our languages permit us to communicate.
Yeah, it relates to this idea of echo chambers. There's one example.
Yes, yes.
Gerard?
No, I do tend to disagree. I'm sorry. For humans, not so much with the. Sorry, I have to disagree on that one. But okay, so I understand on the logic sense, yes, I agree. In the language sense, yes, but from a human sense, or in a, you have a beautiful cat there, and it doesn't have the same language as you, but from a cybernetic perspective, you're having that relationship and you're having a communication, and it does understand you to an extent, and you understand your cat to an extent. So what is that? What is that? Where is the logic behind that one, that level of communication?
This is another project I'm thinking about, and that you're pointing out very directly, and which is very apropos, because it becomes back into the distinction between the use of mathematical language and feelings and emotions. This question of how mathematical language is used is what was brought to mind by Lauren's introduction of his interest in his self. And so I immediately switched my own pictorial thinking representations to semiosis and the imaging involved in semiosis. On the other hand, given the same example of an English-speaking person watching a conversation between a Chinese and a Russian speakers, that English-speaking person could certainly observe the emotions and feelings that were being exchanged between the two, whether it was a peaceful conversation or one of anger and dispute, would be easily observed by the English observer. And so the question that Ram is facing in part, and I have dealt with this for decades, is I reach a mental conclusion about the images that I can form in different structures, different graphs. Whether any type of graph, I have to have an image of it. Then I have to decide, yes, I agree with that picture, or no, I don't agree with that picture. And that moves it into the feeling motive. And what I express is going to be the feeling motive, not the actual logical conclusion that I reached. I'm going to have to switch my mental states from that of being internal rationalizations and reasoning to how do I feel about that form of reasoning? And which one am I going to accept as being valid, useful, or maybe not even valid and useful? Just that I want to say that because I know that she wants me to say that. If I can use that as a situational point of view, So the complexity of the human mind are vast.
I've looked at that. I've looked at the structure.
I have to go now to another meeting, but thank you again, everyone. I'll see you all later.
Garage?
Just a brief comment on that. I've tried to look at that, and I suggest it's what I call a mental network, which is a combination of a schema that's imposed emotionally, and it looks like the ventromedial prefrontal cortex is the core region that's actually handling that. And I've put together some papers on that. Interesting topic.
Could you send me those? Because that's exactly my line of thinking.
Sure.
Garage, time for us to listen to your disagreement or conclusion. Garage is our expert of disagreement.
Well, that is a possibility. Yes, I have a question. Yes, about the different languages that you use in physics and chemistry. In the way you described it, the only difference between the two is actually a technical difference, which means that it is internal to the languages, which is the notion of a partition. So a variable is actually a partition over a set. And that means that I can take any element of the set as my atomic element. So why do you think that they are so different? That's what I was wondering. I'm sorry, this is not disagreement, but it's asking for a technical explanation. Many of the discussions I had with Jerry were accompanied by beer, so I think I am allowed a little bit of a technical question.
No, Gerard, you have hit on a crucial logical question or situation, which I only resolved about 3 or 4 years ago. And that is the conceptualization of logic itself, of reasoning. So getting away from mathematics and just looking at mathematics as being a symbolic logic. And then asking, how do we interpret individual symbols within the symbolic logic? And this question then comes to the issue of what in part was illuminated by the paper on denotation by Russell that I mentioned very early on, which Russell was struggling with this very same question that you asked, but in a slightly different way. The question in terms of a variable or representing a symbol as a variable leads to an indefinite language. In other words, as you said, you can pick out any element as part of the partition and it works for all elements in the variable. That's fundamental, right? And so the question then becomes, what if you only start with one element? And then you can't partition that. And so then you can still do a composition with that single element. In other words, you can add it to other elements, for example. So you can still make a logical operation on a single element without invoking the entire domain, the entire set, the sum of all partitions. And so in simple language, then a composite number is simply the sum of the individual elements.
Mm-hmm.
And so this is the fundamental distinction then between the logic of chemistry and the logic of physics.
Okay.
Is that?
There are some additional questions, but we are now nearing the end of the meeting. But
Well, you can go ahead. Five more minutes. We don't want to miss your thinking.
well, you can't partition something if there isn't a way of putting them together. So it is not simply taking one element out of a set, but the first step is to identify that there is a similarity between the elements of the set. Then you can partition, then you get a variable. So the first question is not only can I take it for a single element, but also what is the role of this notion of a set in between the two operations? Is it possible, for example, to have an open set? Is it possible to have a closed set? As far as I know, variables only apply to a closed set. That was the background to the question.
Oh, yes, I agree with you perfectly on that.
Okay.
So this is precisely why I started the logic in the terms of elements and the table of elements, because those are independent individuals. They are independent terms. They are numerical terms. They have properties, but that doesn't mean that they are some way part of a variable. They are individual logical terms. And so this goes far deeper than your question illuminates, okay? But it goes deeper in the sense that if you look at the formal development of logic in the 1920s, they come into this problem of how do you deal with this calculations, logical calculations that led to Gödel's theorem and that sort of issue. And it revolves exactly around this. How do you symbolize things? The argument eventually went, the successful argument eventually was to describe the notion of definite descriptions of individuals and rather go to Quine's notion of what constitute a logic and the logics that were developed around the notion of conjunction, disjunction, conditionals and biconditionals and negation, and then putting that form of logic in terms of those symbols in terms of truth functions, which were defined in terms of soundness and completeness. And this soundness and completeness argument, which was a restatement of basically Russell's notion of atomic and molecular sentences, then became the grounding or the foundation of symbolic logics. And the development of soundness and completeness is fundamental to formal symbolic logics. The problem and the conflict, which was so difficult to find actually, was that the soundness and completeness means nothing within chemistry because we have defined our terms in terms of elements, of atoms, atoms of meaning. And we do this in such a way that those atoms of meaning have physical properties. And this is why they're called constants. And so the logical constants of the chemical logical system is based not on conjunction, disjunction, division, biconditional and conditionals. No, it's not based on that. Even though those terms, as logical terms, are relevant to the operations on chemical symbols. So it's a distinction of how we're going to use logical symbols that lie at the base. And thank you for asking that question, because I'm certain Ram really much appreciated that question. right?
Yeah, yeah.
Just
No,
one element to check. Is it correct that when you were talking, the name Kripke came into my mind?
Oh, no, I didn't mention Kripke. That's a
No,
whole
no,
other.
but I'm asking.
Oh,
It
you
came
asked.
into my mind.
Yes. No, the Kripke's arguments, if you look at them, it's simply unrelated to chemistry.
Oh, okay.
I mean, that, and the reason is because he has no capability of dealing with nucleus and electrons. Okay, it's just simply, you look at how he formulates his Kripke arguments.
Yeah.
He cannot deal with attractors and repellers, basically.
Hmm.
Okay, and it's really, so when I use the word nuclei and electrons as a binary or polar situation, what I'm actually saying is that these are dynamic attractors and repellers. And nuclei repel each other, electrons repel each other, and the combination of nuclei and electrons form attractors. And this also is of interest to Ram, I'm quite certain. Because it is a very critical, logical distinction that
Yes.
underlies semio-cybernetics.
Okay, thank you.
Okay, guys, do you think we need another session to continue, or we can call it for a day? Yeah, what do you think?
Jason, if you want to do something in 3 months, I would think we could extend these arguments.
In 3 months. Okay.
Well,
Actually,
I mean,
we had two presentation planned today, but there's all times it just volunteered to Jerry because I understand you're doing very heavy lifting. My presentation was only about some suggestions to Rem and Ben. So it's already in the PPT, so it can be omitted here. But if you feel like we reschedule another one, please let me know. Or you can decide now.
well, I didn't mean to cut out. I mean, the discussion was invigorating and useful, I think.
Yeah.
So I didn't mean to cut your time, in that
No,
sense.
no. It's I did that on purpose because I think your topic needs to be thoroughly discussed. Yeah.
So I would say that in 3 months,
In April?
I should be able to address some of the other questions in a more logical fashion. I mean, there's huge gaps in as the questioners have pointed out, there are huge gaps in my reasoning as I went through this. And that is very clear, I think, to people that are knowledgeable about in the area. Huge gaps in my reasoning.
And also a huge gap between your work and Ram's work.
Yes.
And I hope to see them being connected one way.
Oh, that would be fun. That would be fun.
What do you say, Ram?
Just one statement I want to make. So when we are talking about closed systems, we are talking about deterministic systems. Whereas when we are talking about open systems like living systems, they are probabilistic. So when we say emotion is the probability that determines which event is going to happen. So what I've been focusing on is trying to understand how brain becomes the interface and allows us to handle both deterministic and probabilistic systems and how it evolved. And that is what I presented the last time.
Maybe you can build a bridge, starting from your neural activities, forming the concept, symbols, and then the symbols connect with Jerry.
Yeah. And I think Lauren's developments would be quite interesting to include if he's interested.
So maybe you three do another session on April? It's too far from now.
Yeah, that's fine with me.
Okay. Okay, we'll consider an
Thank
April thing.
Just one quick question to Lisa. Lisa, have you heard of Glenn Doman? No, okay, yeah. He lived in Philadelphia. He set up a place called Center for Achievement of Human Potential. He worked with basically brain handicapped people, and then offshoot of that was a thing called Better Baby Institute. He said if we can take even brain damaged people and bring them back a lot of activities, then we should be able to take children right from birth, and by structured input output, we should be able to accelerate the learning process. In fact, both my wife and I took those courses, and we used all those learning materials, and we did homeschooling of our children right in the beginning. It was phenomenal. Like what you were saying, you don't start with symbols. The one thing they told was never show the children alphabets and Arabic numerals. So you show dots or you show paper clips, and you start doing one-to-one correspondence with that, and you don't use symbols.
Yeah, Rob, my career started in special education and Montessori also at the same time.
Yeah, same idea, Montessori idea, right? Our children afterwards went to Montessori school after homeschooling. First 0 to 4, we did like 3 or 4 homeschooling. Then we did the Montessori, and then we went to regular school. Yeah.
So maybe
Even looked at Waldorf.
That's a topic for another session. Lisa, Rem, you want to do another focus conversation on that?
Well, I think what we're really feeling today, for me, the synthesis really is about the importance of framing. And the bridge to me is, like the materials and this ineffable sense of the preciousness of life that's maybe not always reflected in the economies of today. The one that I'm wanting to build is much more about care. But that's the bridge I'd like to make to Charles's question about the reality, to my point about sense make together across age. So my study was not only 25 years experience in all kinds of classrooms, but then I did a research study with an intervention, a mindfulness-based intervention with folks living with, older, frail adults and people living with Alzheimer's and dementia. And so there was an academic journal article written, but the stories are really the gold mine. So
that's a totally different topic.
Yeah, but my point is about a political system and an economic system related to Lauren's work, I think would be an interesting next chapter to follow the discussion from science, methodology, abstract descriptions, and the arguments that we have over those descriptions or definitions in system science to on the ground, how do we live together and build futures?
So Lauren, Rem, Lisa, are you three interested in doing a session around this, which is a different one?
Yeah, I think I need a little more time too, like Jerry,
Yeah,
I'm going into some rest time.
Okay.
But we have these other projects together too.
Keep cooking. Okay.
Yeah, thanks, Jason, for hosting us.
Okay, you're all
Thank you.
welcome, and thank you so much for today.
Thank you.
And
Thanks, Judy.
looking forward to see you in next session.
Okay.
Bye.
Bye.